In this lesson, we're going to be looking at something called the law of sines, which is useful for us when we have triangles that are not right triangles. If we have a right triangle, we're going to want to use sine, cosine, and tangent like we did in the previous sections. But this is looking at special cases where we just have any triangle, not right triangles. The first thing we need to do is know how to label these in order to make it fit into our formula. If we have a triangle ABC, we use capital letters for the points, for the vertices of these. And across from that, I'm going to use a lowercase letter with the same letter, but just the lowercase version of that. And that'll help us keep track of what is opposite of what, because our formula is based on being opposite of this. So this is our law of sines. If I have my angle A here, it's across from the side A, lowercase a. So remember, angles are always grouped inside of your sine function. So we can just remember it that way. Angle goes inside of sine. And it would be equal to any one of these parts. Now usually you're only going to be looking at two of these at a time, but what this is saying is I can take any angle across from the side, sine of any other angle across from the side opposite of that. And it will always fit in this ratio. We could also write this if we were looking for, say, A here. I could start with A over sine of A, and that would be equal to either B or C. So let's say we're using C, and then the angle opposite of that. The important thing is that we're keeping sides and angles opposite of each other, top and bottom. And if I'm using sides on top, I'll use angles on bottom. Angles on top, sides on the bottom. Now in these problems, they haven't given us a picture to this. They are telling us we have a triangle ABC. So the best way to remember these is to just do, and know how they're related, is to just draw a quick sketch. It doesn't have to be accurate. We're just looking at A, B, C. We label it based on what they've given us. Okay, so A is 37, B is 68, and then they say A is 3. We know that that would be opposite of side A, and they ask us to find B. B would have to be across from this. Notice they haven't given us anything about C. We don't need it to solve for B. If I'm looking for B using my law of sines, I'll take that and the sine of the angle opposite of that. That would be my 68. Since I started with the side on top, I'm going to start with the other side here. We know that 3, and the angle opposite of that, 3 is opposite of 37. I will solve that then by multiplying both sides by the sine of 68, which will give me 3 times the sine of 68 all over the sine of 37. And I can plug it into my calculator just like that. Just make sure that your division bar is going over everything. And that's going to come to 4.6. They did ask for the nearest tenth, so that would be my answer. So the steps we did, we sketched, labeled the triangle. We wrote a proportion then relating the parts. That proportion is basically our law of sines formula, and then we solve it. Okay, in the second one, we'll do the same thing. Quick sketch, we'll just label A, B, C, does not have to be accurate. B, that would be across from angle B. It's lowercase, so it's a side. C is across over here. And then B, that angle is 92. They ask us for angle C. So since we're looking for C, let's start with, we'll say the sine of C over. And we're across from 14, so now we'll look at the B here, that's 92, and it's across from 17, so we can use the law of sines here, over 17. This one's going to take a little more work to solve, but it's going to look first like this. But we're going to need to get this C by itself. Remember, we have sine of C, and we want to find what that angle is. We'll use the inverse sine. And we can just keep all of this the same. Now I keep it like this because it's a little bit easier to put this into my calculator like this. Just make sure that everything is grouped inside of the parentheses when you do this. And then this one should come to about 55. They ask for this to the nearest degree. They often ask for the sides to be to the nearest tenth and angles to the nearest degree. In this example, again, we want to draw it first and label it. And notice what we want to find. We want to find A. Now notice that we can't find A right away because we would need to have the angle opposite of that. Right now we don't have enough information. All we have is C here and the angle opposite of that. And we couldn't find B right now because we could find B right now, but that's not what we're looking for. In order to do this one, we should start by finding the measure of angle A, and we can do that because we were already given two angles here. So if I add those together and I subtract that from 180, then we know that we have a 97-degree angle here for A, and then we can fill that in and our formula is complete. We can then solve this by putting in our calculator, and we get A equals 15.3. Okay, the next thing they'll be talking about solving a triangle. When the problem says to solve the triangle, they want all of the angles and all of the sides. So in this one, what we have is angle A, we have angle B, we have side B, and that's it. And we want to find everything here. So let's start, since we have B and that opposite, and we have the angle opposite of A, let's start by looking for A. So we'll set that up as A over the sine of 33. What will that be equal to? Well, we have 14 here is opposite of the sine of 47. Okay, so that's one thing that'll set up, that'll allow us to solve for A. If we want to find C, then we'll do like we did in the last one. We'll add these together, that would give me 80, leaving us with 100 degrees here. And so if we're looking for C, we'll set it up as C over the sine of 100 is equal to, and we have B's already, so we're going to use B. Okay, working this out, this one's going to give me A is equal to 10.4, and this one over here is going to give me C is equal to 18.9. Okay, we're multiplying each side by sine of 100. Over here, multiply by the sine of 33. Now sometimes the law of sines is not going to work out for us. If we have an obtuse angle, it could give us problems, but we'll worry about that more when we come to the next section. Really, we want to use the law of sines anytime where we have a situation where we have at least one angle and the side opposite of that. So if we have a side and the angle across from it, and we have any other part, whether it's an angle or a side, we can use the law of sines.